Okay, today we will be solving some problems on properties of steam in session 4. Okay, in the in the previous session, we have solved the problem 1, so that is using steam table. So all the problems henceforth we are going to solve using steam table. So you have to purchase the steam table book. Then you have to practice at your home how to refer the steam table. Keep solving so one or two problems other than what I explained in the session. So refer the books, and from the book you try to solve the problems, whether it may be a solved problem or it may be unsolved problem. So at the end of this session I'll be providing some problems. So those problems you need to solve in the activity book, then you need to submit at the end as the activity of this subject. So now we'll see the problem 2. So a steam engine obtains steam from boiler at a pressure of 15 bar and 0.98 dry. The steam losses 21 kilojoule of heat per kg as it flows through the pipeline. Pressure remains constant. Calculate dryness fraction of the steam at the engine end of the pipeline. So this was the problem. So read it carefully, understand it. So what is the given data and what he has been asking? So a steam engine obtains steam from boiler at a pressure of 15 bar and 0.98 dry. So he has given the pressure 15 bar and 0.98 dry. So 0.98 dry means, so it is a wet steam, right? Dry means it is a dryness fraction. If we given the dryness fraction, then it is wet steam. The steam losses 21 kilojoule of heat per kg as it flows through the pipeline. So pressure remains constant. So the steam which is 0.98 dry steam that has to pass through the pipeline. So when it passes along the pipeline, so it loses 21 kilojoule of heat, maintaining the pressure constant. Then calculate dryness fraction of the steam at the engine end of the pipeline. So at the inlet the steam is 0.98 dry. So when it comes out of the engine, the outlet, you need to find out the dryness fraction, that is X value. So after losing 21 kilojoule of heat. So this was the problem. So now this is the given data. So from the problem, what is the given here? So the given is P is 15 bar. So dryness fraction X is 0.98. Heat loss is 21 kilojoules per kg. So now referring to the steam table, from steam table corresponding to pressure table 2. As I said, there are 5 tables in the steam book. So now you have to refer the table 2. So the table 2 means wherein the pressure is given. With respect to the pressure, the values or the properties of the steam values are calculated and tabulated. So right, so here you have to refer that, and for a pressure of 15 bar pressure. So if you have the steam table in your hand, just go to the page number 12. So I am referring the steam table by R.S. Kurmi. If anybody is having the same book, open the page number 12. Page number 12. Refer the first column, that is 15 bar pressure is given in the first column. So from the 15 bar pressure column, go along the horizontal. So 15 bar pressure horizontal row, refer all the values are given here. So from that values, HF is 844.6 kilojoules per kg. HF means it is enthalpy of water. And HFG has given. HFG means it is enthalpy of dry saturated steam is given as 1945.3 kilojoules per kg. So then find out the total enthalpy of steam at the boiler end. So enthalpy of steam at the boiler end is HB. This is enthalpy of B, means it is the boiler end. So HF plus X HFG. So from the steam table already you have noted down the values of HF and HFG. Substitute in the formula. So 844.6 plus 0.98 is dryness fraction into 1945.3, then you will get 2751 kilojoules per kg. This is the enthalpy of the steam at the boiler end. It is not at the engine end. From the boiler it has to go to the engine. So you need to find out the steam properties at the engine end. Now heat lost by the steam is 21 kilojoule. What is the heat lost here? When it is flow through the pipe. So the steam is generated in the boiler. When it is generated in the boiler, at the end of the boiler, so the steam is 0.98 dry. So the having the enthalpy of 2751 kilojoules per kg. So when it passes along the pipe and at the end of the engine end, it reaches at the end of the engine end. So it loses the heat of 21 kilojoule. So therefore, enthalpy of steam at engine end is equal to HE is equal to HB, means it is the boiler end enthalpy minus heat lost by the steam. Subtract this, whatever amount of heat is lost here. So this is the total enthalpy of the steam at engine end. So 2751 minus 21, so it becomes 2730 kilojoules per kg. So next, but what he has been asking in the problem, he is asking you to find out the dryness fraction at the engine end. So again, just now you have calculated the enthalpy of engine end. So again, write down the equation. So this is the HE is equal to HF plus X HFG again, right? So where X is dryness fraction at the engine end. Substitute the values. 2730 is equal to 844.6 plus dryness fraction keep as it is, because you need to find out this dryness fraction X only. So X into 1945.3. So again, so bring this value this side, so it becomes negative again. 2730 minus 844.6 is equal to X into 1945.3. So then X is equal to, so bring this value down this side, so it becomes this side. So X is keeping as it is. X is equal to 1885.4 divided by 1945.3. So this is equal to 0.9693. So I'll write it as approximately 0.97. This is the value of X. So it means it's the dryness fraction. So the dryness fraction at the engine end is 0.97. But at the boiler end it was 0.98. When it reaches to the engine end, so the dryness fraction becomes 0.97, right? So then next go to the problem 3. So in the problem 3 again, read it carefully. Calculate the internal energy of 1 kg of steam at a pressure of 10 bar when the steam is, first case 0.9 dry, second case dry saturated. The volume of water must be neglected. The initial volume, how much water you have taken, the initial volume of the water is neglected. It is given in the problem, right? So again he has given the pressure of 10 bar again. So again you need to refer the steam table 2, that is with respect to pressure again. So with respect to the pressure 10 bar, then you write down the standard values of the properties of steam, that is enthalpy, initial enthalpy, that is enthalpy of water, then enthalpy of dry steam. You have to note it down from the steam table. Again, refer the steam table. If again whoever is having the Kurmi steam table, again you refer page number 11. Open the page number 11. In the page number 11, first column, find out 10 bar. The 10 bar again follow along the row wise. When you follow along the row wise, the HF value is given as 762.6 kilojoules per kg. This is the enthalpy of water. Then HFG is enthalpy of dry steam, that is 2013.6 kilojoules per kg. Then you have to find out the VG. This is specific volume of dry saturated steam. This is also given. This is also given in the steam table with respect to 10 bar, that is 0.1943 metric cube per kg. So first case, find out the internal energy of 1 kg of steam when x is equal to 0.9. Right, it is wet steam now, because given as x is dryness fraction. Whenever dryness fraction is given, then the steam is wet steam. So internal energy formula, u is equal to, already, u is equal to what? U is equal to q, u is equal to q minus w, because u is equal, q is equal to u plus w. So you need to find out internal energy, so u is equal to q minus w. So for the q, I am writing here hf plus x into hfg. This is the q. So why this is q? Because we are calculating at constant pressure, so this is called as enthalpy. Enthalpy and the q both are same. In this case, I am calling both are same. Why? Because when the pressure is kept constant, the whatever amount of heat you are supplying to the system, that itself we call it as the enthalpy. So now this is hf plus x sfg, because he has given the dryness fraction, so I introduce x here. If dryness fraction is not given, then directly we would have taken hf plus hfg. So minus 100 pxvg. So this is the work done. Work done means, what is the work done? PdV. P means pressure and change in volume. So it is PVG, but the steam is wet steam. So I'm introducing the dryness fraction x in between. So I told you in the session 3 why I have taken 100 here, because the bar you need to convert it into a kilojoules. When you convert it into a kilojoules, 10 to power of 5 would become 100 here. Right? So substitute all the values what you had taken from the steam table, 762.6 plus. So x is dryness fraction, so 0.9 into 2013.6 minus 100 into 10 into 0.9 into 0.1943. So after solving, so you will get the answer as 2400 kilojoule. This is the first case. So in the second case, internal energy of 1 kg of steam for dry saturated steam. So in the above case, he said it is wet steam, so we have introduced the dryness fraction x in between. But now in the second case, he is saying it is dry saturated steam, so you have to remove x. There is no wet steam here, so h instead of hf plus x here, I have removed x because it is a dry saturated steam. So hf plus hfg minus 100 pxvg. Now I am removing x here because it is dry saturated steam. If it is wet steam, we would have introduced x here and here, but it is not a wet steam, right? It is dry steam. So substitute all the values. So hf is 762.6 plus 2013.6 minus 100 into 10 into 0.1943. So after calculating, you will get the answer as 2581.9 kilojoule. So coming to the fourth problem. So again, read it now. A sample of 1 kg of steam at a pressure of 15 bar exists with a dryness fraction of 0.8. What is the dryness fraction? Again 0.8 he has given. Once again dryness fraction comes, again it is a wet steam. So now he is asking you to find out, determine the following properties in each case. In each case means, first one is enthalpy, volume, entropy, the next external work, internal energy. So all these 5 properties you need to find out for a given property of steam. So then solution, given data is, again in the problem he has given 15 bar. Again go back to the steam table. If you are using Kurumi book, open the Kurumi book, go to the page number 12. Again refer the pressure 15 here. For the pressure 15, from the steam table write down the values SF. HF is 844.6 kilojoules per kg. Remember, whatever he has given in the steam table, these are all the experimentally calculated values for 1 kg of steam. So the table HF is 844.6 kilojoules per kg. So then HFG is equal to 1945.3 kilojoules per kg. TS means saturation temperature. You need to note it down, saturation temperature also. Why the saturation temperature is required now? Because he has asked you to find out the different properties here. So this TS means after the pressure, next immediate column is of saturation temperature column. So refer the second column with 15 bar. So you will find out 198.3 degrees Celsius. So again refer the entropy. SF is 2.314 kilojoules per kgK. SFG is equal to 4.127 kilojoules per kgK. Again Vg from the steam table, Vg is equal to 0.1317 metric cube per kg. Now, so according to the problem, what he is asking is I enthalpy. So now I enthalpy is equal to, that is H is equal to HF plus X HFG. So whatever the value of H you need to find out, that is enthalpy. So first you have to see what is the HF. HF is, it is the enthalpy of water. So from the steam table, the enthalpy of water is 844.6. So plus, so the given steam is wet steam. So substitute the value of X, that is dryness fraction is 0.8, multiply it with the HFG value. So that is 1045.3. So that will give you the 2400.84 kilojoules per kg. So the next one, he is asking you to find out the specific volume. So since the given steam is the wet steam, so the specific volume V is XVG. So this is 0.8 into 0.1317, multiply with this value. So you will get it 0.10536 metric cube per kg. So the next third one is entropy. So again entropy, the formulas remains same here. Again SF plus XSFG. Substitute the values. These values are, you have noted down from the steam table. So 2.314 plus 0.8 into 4.127 is equal to 5.6156 kilojoules per kgK. Next fourth one is external work, that is W. So 100 pxvg. So right, again it is a wet steam. So xvg 100 into 15 into 0.8 into 0.1317. So it is 158.04 kilojoules per kg. So now find out internal energy. So that is U is equal to H minus W. H means it is Q. So in this case, Q itself I am treating it as H. Why? Because the heat is supplied at constant pressure. So now substitute the values 2400.84 minus 158.04. So this will give you 2242.8 kilojoules per kg. So this is the 5 properties you have calculated from the given data using the steam tables. So next we will go to the problem number 5. So in the problem number 5, again read it carefully. So make uses of the given data. Find the quantity of heat required to produce 1 kg of steam at a pressure of 6 bar at a temperature of 25 degrees Celsius under the following conditions. So this is the given data. From this given data, so what he is asking is from the 3 cases. First case, when the steam is wet having dryness fraction of 0.9, when the steam is dry saturated, and when it is superheated at a constant pressure at 250 degrees Celsius, right? So next again, assuming the mean specific heat of superheated steam to be 2.3 kilojoules per kgK. He has given that assume the mean specific heat of superheated steam is 2.3 kilojoules per kgK. Next solution is, so given is again pressure 6 bar, then the initial temperature of water is 25 degrees Celsius. The dryness fraction given is 0.9. Then T soup means temperature of superheated steam is 250 degrees Celsius. And the specific heat of superheated steam is 2.3 kilojoules per kgK. This is assumed in the problem. So from the steam table again, to go to the P, again, if whoever is having the Kurmi book of steam table, refer page number 11, again the 6 bar pressure. So 6 bar pressure, the pressure is given in the first column, refer 6 bar, along the 6 bar move horizontally then you will get HF as 670.4 kilojoules per kg. HFG means it is enthalpy of dry saturated steam, that is equal to 285 kilojoules per kg, 2085 kilojoules per kg, and TS, that is saturation temperature, again from the steam table. This is of 6 bar pressure. It is given as 158.8 degrees Celsius. And now the case 1 is when the steam is wet with X is equal to 0.9. So again it is a wet steam. The dryness fraction is 0.9. So we know that the enthalpy or the total heat of 1 kg of wet steam, that is H wet, is equal to HF plus XHFG. So already you have noted down these values from the steam table. Substitute the values in this equation. So that is 670.4 plus 0.9 is dryness fraction into 2085. That will give you the answer as 2546.9 kilojoule. Since the water is at a temperature of 25 degrees Celsius, he told in the problem itself the steam is initially at a temperature of 25 degrees Celsius. So it means that when the steam to be reached to 25 degrees Celsius, it would have consumed some amount of heat. So that heat you need to find out now. Therefore, the heat already in water is, you know already, this is 4.2 into TW. What is 4.2? It is a specific heat of water. Multiply the specific heat of water with the given temperature. So you will get it, this much amount of heat is required to bring the water to the temperature of 25 degree Celsius. So 4.2 into 25, so it will give you 105 kilojoule. Therefore, heat actually required. So this heat, whatever 105 kilojoule is there, that you need to subtract from the already calculated value. So that is 2546.9 minus 105. So that is equal to 2441.9 kilojoule. So similarly, then the second case, when the steam is dry saturated. When the steam is dry saturated means there is no dryness fraction. So the dryness fraction is not comes into picture in this case now. So removing the dryness fraction, write it once again. We know that the enthalpy or the total heat of 1 kg of dry steam, that is H dry, is equal to HF plus HFG. Since it is dry, there is no X factor here. That is equal to 670.4 plus 2085. So that will give the answer 2755.4 kilojoule. So therefore, heat actually required would be 2755.4 minus 105. This is 105 is because of what? This is the initial heat supplied to the water to reach a temperature of 25 degrees Celsius. That you need to subtract it from the calculated value. So that will give you 2650.4 kilojoule. The third case, when it is superheated at a constant pressure at 250 degrees Celsius. So the steam becomes superheated when it reaches a temperature of 250 degrees Celsius, keeping again the pressure constant. We know that enthalpy or total heat of 1 kg of superheated steam, that is H sup, is equal to HF plus HFG. So this HF plus HFG is a dry saturated steam. After dry saturated steam, there would be a superheated steam. So whatever the amount of heat you are supplying after dry saturated steam, that you need to add it to it. That is plus Cp T sup minus T saturation temperature. This is Ts. So that is equal to 670.4 plus 2085. Or instead of this also, I can write this one more equation as, this is H dry. I can write it as H dry also. This is H dry. H dry plus Cp into T sup. This is T sup minus Ts. So it is one more equation. You can write H dry. Instead of writing HF plus HFG, you can write it directly H dry, because H dry you have already calculated here this value, right? So that also you can write it. If you write it that, then if you calculate this value, it works out to be 2965.16 kilojoule. Now you can find out what is the actual heat you have supplied. It means actual heat you need to supply means you subtract it whatever the initial heat you have given to the water to reach a temperature of 25 degrees Celsius. That is 2965.16 minus 105. So that will give you 2860.16 kilojoule. So it is very clear. So I'll explain in Kannada this problem. So let us see. ಸೊ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಅವನು ಏನು ಹೇಳ್ತಾ ಇದ್ದಾನೆ ಅಂತಂದ್ರೆ, ದ ಟೆಂಪರೇಚರು ದ ಪ್ರೆಷರ್ 6 ಬಾರ್ ಇದೆ, 1 kg ಆಫ್ ವಾಟರ್ನ ತಗೋತಾ ಇದ್ದಾನೆ. ಆ 1 kg ಆಫ್ ವಾಟರ್ ಇನಿಷಿಯಲಿ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ ಅಂದ್ರೆ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ಐತಿ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ. 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ದಂತ ವಾಟರ್ ನಿಮಗೆ ಕೊಡ್ತಾ ಇದ್ದಾನೆ ಅಂತಂದ್ರೆ, ಆ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಆ ವಾಟರ್ ರೀಚ್ ಆಗಬೇಕಾಗಿತ್ತಂದ್ರೆ ಎಷ್ಟು ಹೀಟ್ ಕೊಟ್ಟಿರ್ತಾನಲ್ಲ ಆ ಹೀಟನ್ನು ಎಲ್ಲ ಕೇಸಲ್ಲಿ ನೀವು ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. ಸೊ ಅದೇ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ವೆನ್ ದ ಸ್ಟೀಮ್ ಈಸ್ ವೆಟ್ ಹ್ಯಾವಿಂಗ್ ಡ್ರೈನೆಸ್ ಫ್ರಾಕ್ಷನ್ 0.9 ಇಟ್ ಇಸ್ ವೆಟ್ ಸ್ಟೀಮ್. ಸೊ ಅದಕ್ಕೆ ಅವನು ಹೇಳ್ತಾ ಇದ್ದಾನೆ ಎಲ್ಲ P6 ಬಾರ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಸ್ಟೀಮ್ ಟೇಬಲ್ ಇಂದ ಇವೆಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ನಾವು ಇಲ್ಲಿ ಹಚ್ಕೊಂಡ್ಮೇಲೆ ಯಾವಾಗ ನೀವು ಎಂಥಾಲ್ಪಿ ಆಫ್ ವೆಟ್ ಸ್ಟೀಮ್ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ತಿರೋ ಅವಾಗ HF ಪ್ಲಸ್ XHFG ಇದನ್ನೆಲ್ಲ ಮಾಡಿದ್ಮೇಲೆ ಈ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ನಿಮಗೆ, ಇಷ್ಟು ವ್ಯಾಲ್ಯೂ. ಸೊ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ 2546.9 ಕಿಲೋಜೌಲ್ ಬಂತು. ಇದು ಎಷ್ಟು ಹೀಟ್ ಅಪ್ಪ ಅಂತಂದ್ರೆ 0 ಡಿಗ್ರಿ ಇದ್ದಂತ ವಾಟರ್ ಅನ್ನ ನೀವು ಡ್ರೈನೆಸ್ ಫ್ರಾಕ್ಷನ್ 0.9 ಗೆ ಬರೋವರೆಗೂ ಹೀಟ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಹೀಟ್ ಕೊಡ್ತಿರ್ತೀರಿ ನೀವು ಅಂತಂದ್ರೆ 2546.9 ಕಿಲೋಜೌಲ್ ಹೀಟ್ ಅನ್ನ ಕೊಡ್ತೀರಿ. ಯಾವಾಗ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ದಂತಹ ವಾಟರ್ ಅನ್ನ 0.9 ಡ್ರೈನೆಸ್ ಫ್ರಾಕ್ಷನ್ ಬರೋವರೆಗೂ ನೀವು ಅದನ್ನ ಕಾಯಿಸಿದಾಗ ಎಷ್ಟು ಹೀಟ್ ಸಪ್ಲೈ ಮಾಡ್ತೀರಿ ನೀವು 2546.9 ಕಿಲೋಜೌಲ್ ಸಪ್ಲೈ ಮಾಡ್ತೀರಾ. ಆದ್ರೆ ನಿಮ್ಗೆ ಕೊಟ್ಟಂತಹ ವಾಟರ್ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ಇಲ್ಲ. ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಎಷ್ಟಕ್ಕಿದೆ ಅಂತಂದ್ರೆ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಗೆ ಇದೆ. 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ದಂತ ವಾಟರ್ನೇ ನಿಮ್ಗೆ ಕೊಡ್ತಾ ಇದ್ದಾನೆ ಅಂದ್ಮೇಲೆ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿ ನೀವು ಕಂಡುಹಿಡಿದಂತ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಏನ್ ಕೊಡುತ್ತೆ ಅಂದ್ರೆ ಯಾವಾಗ ವಾಟರ್ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇರುತ್ತೋ ಆ ವ್ಯಾಲ್ಯೂನ ಕೊಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ಗೆ ನೀವು ಎಷ್ಟು ಹೀಟ್ ಅನ್ನ ಕೊಟ್ಟಿರ್ತೀರೋ ಆ ಹೀಟ್ ಅನ್ನ ಬಂದಂತಹ ಈ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ನೀವು ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಈ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದಾಗ then you will get actual heat supplied to reach the dryness fraction of 0.9 ಅಂತ ಸಿಗುತ್ತೆ. ಸೊ ಅದನ್ನ ಮಾಡಿದಾಗ we will get it the answer as 2441.9 ಕಿಲೋಜೌಲ್ ಅಂತ ಸಿಗುತ್ತೆ. ಸೊ ಅದೇ ರೀತಿ ಎಲ್ಲಾ ಕೇಸಲ್ಲಿ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. ದ ಸೇಮ್ ಥಿಂಗ್ ಇವನ್ ಇನ್ ದ ಬಿ ಕೇಸ್ ಇಟ್ ಇಸ್ ಡ್ರೈ ಸ್ಯಾಚುರೇಟೆಡ್ ಸ್ಟೀಮ್ ಇದ್ದಾಗ ಅಂದ್ರೆ ಅಗೇನ್ ಮತ್ತೆ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ಇದ್ದಂತಹ ವಾಟರ್ ಅನ್ನ ನೀವು ಡ್ರೈ ಸ್ಯಾಚುರೇಟೆಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತಂದ್ರೆ ಎಷ್ಟು ಬೇಕಪ್ಪ ನಿಮ್ಗೆ ಹೀಟ್ ಅಂದ್ರೆ 2755.4 ಕಿಲೋಜೌಲ್ ಹೀಟ್ ಬೇಕಾಗುತ್ತೆ. ಆದ್ರೆ ನಿಮಗೆ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ದಂತಹ ವಾಟರ್ ಅನ್ನ ನಿಮಗೆ ಕೊಟ್ಟಿಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. ಅವನು ಎಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ, ಆಲ್ರೆಡಿ ದ ವಾಟರ್ ಈಸ್ ಅಟ್ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. ಆ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ರೀಚ್ ಆಗಕ್ಕೆ ನೀವು ಏನ್ ಇನಿಷಿಯಲಿ ಹೀಟ್ ಅನ್ನ ಕೊಟ್ಟಿರ್ತೀರೋ ಆ ಹೀಟ್ ಅನ್ನ ಈ ಆನ್ಸರ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಆಕ್ಚುಯಲ್ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಸಪ್ಲೈಡ್ ಟು ದ ವಾಟರ್ ಟು ಗೆಟ್ ಅ ಡ್ರೈ ಸ್ಯಾಚುರೇಟೆಡ್ ಸ್ಟೀಮ್ ಅನ್ನೋದು ಸಿಗುತ್ತೆ. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಬಂದಂತ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ 105 ಕಿಲೋಜೌಲ್ ಅನ್ನ ನೀವು ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ದಟ್ ಈಸ್ 2650.4 ಕಿಲೋಜೌಲ್. ಸೊ ಅದೇ ರೀತಿ ಒನ್ ಇನ್ ದ third case also when the steam is superheated steam. So ಅಲ್ಲಿ ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಿದ್ದ ಅಮೌಂಟ್. ಸೊ ಫ್ರಮ್ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಇಂದ ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತೀರಿ. ಸೊ ಅವಾಗ ಇಲ್ಲಿ ಬಂದಂತ ಆನ್ಸರ್ 0 ಡಿಗ್ರಿ ಇರುತ್ತೆ. ಸೊ ಅದರಲ್ಲಿ ನೀವು ಆಲ್ರೆಡಿ 25 ಡಿಗ್ರಿ ಇರೋದ್ರಿಂದ ಬಂದ ಆನ್ಸರ್ ಅಲ್ಲಿ 105 ಅನ್ನ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಅವಾಗ ಎಷ್ಟು ಹೀಟ್ ಬೇಕು ಅಂತ ನಿಮಗೆ ಸಿಗುತ್ತೆ. ಸೊ ಸಿಮಿಲರ್ಲಿ ವಿಲ್ ಸಿ ದ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 6 now. So this is a steam enters an engine at a pressure of 12 bar with 67 degrees Celsius of superheat. So as given superheat. Superheat means the steam is supersaturated steam. So right, it is exhausted at a pressure of 0.15 bar and 0.95 dry. Find the drop in the enthalpy of the steam. So it means the steam is at a pressure of 12 bar, 67 degrees Celsius of superheat. There is no dryness fraction here. it means it is completely superheated steam. At 12 bar A, 67 degrees Celsius temperature A, the steam is superheated. So when that steam is exhausted with the exhaust pipe, the pressure drops to the 0.15 bar. 12 bar iddanತಹ pressure 0.15 bar ಆಗಿಬಿಡುತ್ತೆ. Then now the steam becomes the wet steam. It is not a superheated steam. So when the steam gets expanded, then it converts superheated steam to the wet steam. ಆ ಕೇಸ್ ಆ ರೀತಿ ಆದಾಗ find the drop in enthalpy of the steam ಅಂತ ಕೇಳ್ತಾನೆ. 12 bar 67 degrees Celsius temperature ಇದ್ದಾಗ ನಿಮಗೆ ಸ್ವಲ್ಪ some amount of heat is required to convert this into a superheated steam. When it exhausted, so then at that time that steam becomes a wet steam, that is with a dryness fraction of 0.95. So ಇಲ್ಲಿ ಏನಾಯ್ತವಾಗ dryness ಅಂದ್ರೆ wet ಆದಾಗ then you are losing some amount of heat. So ಎಷ್ಟು amount of heat ಅನ್ನು ನೀವು ಲೂಸ್ ಮಾಡ್ಕೊತಾ ಇದ್ದೀರಾ, ಸೂಪರ್ ಹೀಟ್ ಇದ್ದಿದ್ದು ವೆಟ್ ಆಗ್ತಾ ಇದೆ ಅಂದಮೇಲೆ you are losing some amount of heat. So now he is asking you to find out how much amount of heat you have lost in this conversation. So that he is asking now. Again solution. So given, write it, what is the given? So that is the given is P1 12 bar. Here written P1 is written. Why? Because this P1 is drops to 0.15 when it becomes wet steam. So P1 is 12 bar. So T soup minus Ts, he has given 67 degrees Celsius. This is the superheat. As I said, superheat. Superheat means it is something like this. So at this point is a dry saturated steam. At this point it becomes the superheated steam. So the temperature difference from here to here. So this is a saturated temperature and this is T soup. That is the superheated temperature. So when you subtract from here to here, so that he has given superheat. So that is 67 degrees Celsius. Then P2 is 0.15 bar it is. Then when the pressure drops from 12 bar to 0.15 bar, then it becomes the dryness fraction is 0.95. So again refer the steam tables. So pressure is 12 bar. So if the 12 bar, refer once again Kurmi steam table book. Again open the page number 11. In the page number 11, so last but one, refer 12 bar pressure is there. Along the 12 bar pressure, move horizontally. Then note it down the value of HF. HF is given as 798.4 kilojoules per kg. Then HFG is given as 1984.3 kilojoules per kg. So we know that enthalpy or total heat of 1 kg of superheated steam. So in the superheated steam, he has not given the specific heat of superheated steam. So in this case, we are assuming the Cp as 2 kilojoules per kg. This is the assumption. It is not given in the problem. We need to assume this because this value is there in the formula of the superheated steam. So H soup is equal to HF plus HFG. HF plus HFG will give you the enthalpy of dry steam. So for the dry steam, you need to add it Cp T soup minus Ts. So 798.4 plus 1984.3 plus 2 into 67. This will give you the 2916.7 kilojoules per kg. So this is the amount of heat required to convert the water from 0 degrees Celsius to the 67 degrees Celsius superheat. So this is the amount of heat required. So now next, again refer the steam tables at pressure P2 now. So when the pressure was 12 bar, at 12 bar pressure drops to the 0.15 bar. So there it is going to lose some amount of heat. So now you refer the steam table again for a pressure of 0.15 bar. So again go to the page number 7. Go to the page number 7. For the page number 7, you refer 0.15. So that is the value of HF. HF is 226 kilojoules per kg. HFG is equal to 2373.2 kilojoules per kg. We know that enthalpy or total heat of 1 kg of wet steam. Right, wet steam now. So when dryness fraction comes into picture, it is wet steam. So substitute HF plus XHFG. If X is not there, then this becomes dry. Now it is wet, so I am introducing X here. So HF plus XHFG is equal to 798.4 plus 0.95 into 1984.3. So this is equal to 2111 kilojoules per kg. Therefore, a drop in enthalpy of steam. So now subtract the initial value from the just now calculated value. So you will get it as 805.7 kilojoules per kg. This is a drop in the enthalpy. So when the 12 bar pressure is reduced to 0.15 bar pressure, then definitely there is a loss of energy, there is a loss of heat also. So that heat he asked you to calculate. So now that heat is 805.7 kilojoules per kg. So thank you.